जो टेक्निकल का काम साक्षी कर सकती है और कोई कर सकता है Good morning, students. Welcome back to physics class. This side Pooja Sharma, your physics teacher. I hope you all are fine, you all are healthy. So let's begin up with the physics class. We are going to wait for 2 minutes. Let everybody in. And electromagnetic spectrum chapter we have done in the previous class. I hope there is no doubt. Homework which I have given to you, we are going to have that by Wednesday. Okay? And today we are going to proceed on with the next, that is sound chapter. We are going to proceed on with chapter sound. So 3 students are already there. Kindly send me the names. I get to know that you all are present. And we are going to have lesson 5 also by 1:40. Fine. And whatever we are left up with, we are going to cover in that lesson. Kindly be ready with your books. Have a pencil or a pen in your hand to underline the main keywords. Okay, so Isha is asking about, ma'am, can you tell which homework you have given? So, Isha, we have done electromagnetic spectrum in the previous class. Fine. In that topic, in that chapter, there is one topic where it is given the uses and the hazards of the different waves. Fine. The uses and the hazards of the different waves, for example, gamma waves. Then I told you to make a table. You have to make a table like this. Here you are going to write about the wave type. Then you will be writing about the uses. Then you will be writing about the hazards. The problems which you can have because of that wave. Fine. For example, the first one is your gamma rays. You can write about the uses of gamma rays over here, that it can be used in the medical purposes, that can be used for treatment of the cancer and all. Then you can write about the hazards of this gamma rays, because they have a lot of frequency, energy level बहुत high होता है. So whatever the hazards are you have based upon that, you are going to write it. Similarly, second way you will be writing here its uses, its hazards. Fine. This is the last topic of your previous chapter, electromagnetic spectrum, which I have given as a homework. And continuously you are having the classes, so you are going to do this till next Wednesday. Because next Wednesday we are going to have the class, so you can complete it till that time. Okay, ji. Let's proceed on with sound chapter. First of all, what is sound? Bacha, please have your book along with you. So that all the keywords, I'm going to read it from the book. जो भी keywords आते जाएंगे साथ साथ में important lines, you can keep underlining those. Fine? So sound is what? Sound is the form of energy which enable us to listen. If we don't have the sound energy, we are not able to communicate better with one another. Fine. And it is which form of wave? Is it longitudinal or transverse? We have done in the previous class, if you remember, the previous section में हमने करा था that we have two kinds of waves. One is longitudinal wave and one is transverse wave. The wave which is going to be perpendicular to the surface, that is the transverse, and which goes parallel, that is the longitudinal one. Sound comes in which category? Is it longitudinal or transversal? Hanji, is it longitudinal or transversal? Very good, Isha. This is longitudinal wave. Why this is longitudinal? Because it propagates along the axis. In sound, you have this, let's say, one molecule, this is second molecule, this is third, this is fourth. Fine. One molecule, it is going to strike with the second one. This is going to strike with the third, then the fourth, and so on. Fine. So in this case, you will not be having the perpendicular, but it is parallel to the axis. So we say this is the kind of longitudinal wave. Okay? Okay, now reading from your book. Sound is caused by vibrations, for example, of the front of the violin or the cello, or of the column of the air inside the trumpet. Fine. So we have sound, it is due to the vibration. That I have already told you that if you have sound, fine, suppose you have a source and a listener. Source means from where the sound is going to be produced. Let's say over here. Not the source, we can have it like transmitter. Instead of source, we can have it transmitter. Transmitter means which transmit. Fine. Source भी लिख सकते हो, but transmitter is the best one. Fine. The actual term which we can use. Transmit is going to transmit the signal. Then you will be having here a receiver. Receiver which is going to receive the signal. Fine. So transmitter the signal sent किया, receiver is going to receive. But if there is nothing in between, then the signal is not going to be received by the receiver. Receiver signal तभी receive करेगा if there is something in between, that is molecules. Molecules होंगे तभी आगे pass on होगा signal, नहीं तो नहीं होगा. Now how these molecules are going to work? Transmit send the signal. That energy is going to strike onto this first molecule. This molecule is going to vibrate. Fine. ये molecule vibrate करेगा. It go in the forward and the backward direction. While doing so, it strikes with the second molecule. Second molecule keep moving forward, backward. While doing so, it strikes with the third molecule, and then the energy reaches till the receiver. Okay, now understand one more thing over here. In between the transmitter and receiver, here we have only 3 molecules in between. Okay? Now, if there's going to be more molecules, let's say we have one molecule here, one molecule here, one molecule here, one over here, a number of molecules are there. तब ट्रांसमिशन फास्ट होगी कि स्लो होगी? Is the transmission going to be faster in this case or slower in this case? How the transmission is going to be in this case? And is it going to be faster or slower? Very good. It is going to be faster. How it is faster? Because see, we have a molecule here, second molecule here, third molecule here. They are very close to one another. Means the time to pass the energy decreases. Because they are very close, so the time which is wasted just to pass the energy from one molecule to another, it's going to be decreased. और आपकी जो propagation है, जो transfer होना है from the transmitter to receiver, it is going to increase. Right? The speed of sound increase हो जाएगा. On the other hand, if you will be just having, let's say, the 2 molecules, बहुत कम molecules हैं. In this particular space, there are only 2 molecules present. Now the speed is going to increase or decrease? Now it is going to decrease because this molecule take a lot of time to reach to this molecule, and then this molecule will take time to reach to the receiver. जितने molecules increase करेंगे, time of propagation decrease कर जाएगा, speed increase हो जाएगा. Fine. If molecules are less, time of propagation increases. Time ज़्यादा लगेगा. So speed उतना ही reduce हो जाएगा. Fine. अगर ज़्यादा molecules हैं तो फटाफट आगे speed pass होती जाएगी, आगे energy pass होती जाएगी. तो मतलब speed ज़्यादा. From here we can conclude that sound travel faster in solids. Fine. उसके बाद slow in liquids and very slower in gases. एक और चीज लिखेंगे, not in vacuum. पॉइंट समझ में आया? Faster in solids. Why? क्योंकि solids में in a particular place we have a lot of molecules, and the molecules are almost close to one another. Fine. Because of which what happened? The time of propagation वो decrease कर जाएगा. One after the other, the molecules they are going to collide with one another, and they keep on passing the energy. Fine. Then you have liquid, जिसमें आपके जो molecules हैं वो थोड़े-थोड़े distance पे होंगे. It means the time increases और speed decrease कर जाएगा. Then talking about gases, the molecules are very far apart, so the time increases more, speed decreases. Then the next in vacuum. Vacuum में क्या होगा? You have no molecule. So if you have no molecule, it means what it means? That there is nothing to propagate. There is nothing which can let you have it like this. This is transmitter, this is receiver, and in between there is no molecule present. So sound produced होगी. Fine, it gets produced. Production of sound is going to be there, but propagation it is not going to be there. Why? Because there is no molecule to pass it on. Sound produced हुआ, but there is nothing you can pass it on to the receiver. So sound is produced but not propagated. I hope it is clear. Very good. Kirat, good morning. Mehtab, good morning. Navjot, Dilpreet, Isha. Very correct answer. Chale. Moving on to the next page, page number 188. Sound is a longitudinal wave. The compression are close together. The rarefaction, the vibrations which are further apart of the sound result in small differences in the air pressure. Like other longitudinal waves, sound can be reflected, refracted, diffracted as well. The sound must have a medium through which it can pass. Unlike the electromagnetic waves, the sound cannot travel through vacuum. So this is what we have done in the previous class. हमने क्या किया था? Electromagnetic spectrum. In that case, what we have done? That electromagnetic spectrum, if you can pass it through vacuum, ये जो आपका electromagnetic waves हैं, they pass through vacuum with a speed of 3 into 10 raised to power 8 meter per second. Whereas sound, in case of vacuum, it is not there. It will not propagate. The reason behind it can be asked directly in the paper that what is the reason behind. So the reason is that for the propagation of sound we require medium. हमें क्या चाहिए? हमें medium चाहिए. Fine. But which we don't have. So the sound do not propagate in vacuum. Okay? So you can write it on your book somewhere aside, or जहाँ पे medium word लिखा है, it is highlighted there. You can underline that line. Sound needs medium to travel, or you can say for its propagation. Sound need medium for its propagation, or sound need medium to travel. Okay? Okay, ji. Moving on. How sound need medium to travel? Let's do this. These are the molecules. First of all, we are going to talk about what they have written, that in sound we have the compression, we have the rarefaction. What is that? See, when I am going to apply force onto this molecule is going to come closer to the next. This molecule is going to come closer to the next. It means the molecules are going to be like this. तो थोड़े आगे वाले molecules होंगे, this will be apart, और ये molecules one, we are going to apply force onto one molecule, it will strike to the second is going to strike to the third, and the molecules become close like this. Fine. So this region where they get compressed, we call it as compression. We call it as compression. Fine. Now after this, what happens? This molecule ये आगे नहीं जाएगा, ये जाएगा इसके साथ टकराएगा और वापस. It will go forward and backward. Same second, it will go forward, backward. Fine. Now what happens? This, once they get compressed, compression formation हुआ, then they will be apart. And this molecule is going to apply the force onto the next molecule. These are going to be compressed. Fine. So, when they come close to compression, when they move apart, this is what we say rarefaction. What we say, this is compression. When they are compressed, when they are close, and when they move apart, that is the rarefaction. See, you can understand from the name written, compression means when they get compressed. Rarefaction, rare means when the molecules are rare. Fine, so rarefaction. Okay? Compression and rarefaction. need a medium to travel. If you have molecules, if you have medium, it can be solid, it can be liquid, it can be gases. But if you have medium, only then the sound is going to travel. If you do not have medium, the sound will not travel. क्योंकि sound को क्या चाहिए? Molecules चाहिए. Molecules means medium चाहिए. Medium means molecules चाहिए. Fine. So if you have that, sound will travel. Otherwise, it will not travel. Okay? How we can have it? Let's say we have this jar, a glass jar, and we have a bell inside. Fine, it is hanged inside the bell, inside the jar. Fine. And from the top it is, or let's say it's open. Fine. यहाँ पे हमने इसको अटैच किया है. We have a switch over there and the electricity supply, whatever. Fine. Now when we on the switch, the bell will ring and we are able to hear. Fine. Now I am going to close the top of the jar. That is the lid. Fine. Now again you ring the bell. The bell will ring. You are able to hear it. Slow होगा voice क्योंकि हमने उसको बंद कर दिया. तो maybe the level reduces, but still you will be able to hear it. The reason behind it, this jar, इसमें एक तो bell है और क्या है? It's air inside. Fine, air है ना? Air means you have a lot of molecules. Maybe they are not so close to one another, लेकिन molecules तो हैं. So when the bell rings, the bell vibrates. You know about that hammer? Fine. When it strikes, it keeps vibrating. It collides with the nearby molecules. They vibrate. They collide with the next of the molecules, and the sound passes on. So आपको सुनाई देगा. Fine. If the lid is not, the top is not closed, तो थोड़ा ज़्यादा सुनाई देगा. If you just close the top opening, then maybe the level reduces, but you will be able to listen. Fine. Now we are going to attach one vacuum pump over here. यहाँ पे हमने क्या attach कर दिया? Vacuum pump attach कर दिया. And we are going to use this vacuum pump. It's going to suck all the air which is present inside. ये सारे air molecules बाहर आ जाएंगे. Maybe you have just taken out few of the air molecules. Fine. और ये बाकी 1, 2, 3, 4, 5, 6, 7. The rest of the 5, 7 molecules, they get spread like this. Fine. Now you ring the bell. क्योंकि अभी भी अंदर molecules हैं, so you will be able to hear it. But a very feeble sound, a very slow sound, feeble one, which you can say, बहुत कम सुनाई देगा, लेकिन सुनाई जरूर देगा. Fine. Now again use the vacuum pump and remove all the molecules from the jar. सारे molecules को हमने बाहर कर दिया. Now there is no molecule left in the jar. Now when you are going to ring the bell, definitely the bell is going to ring. Fine. Definitely there is going to be the production of sound, but hammer strikes, it vibrates, sound is going to be produced. क्योंकि sound कैसे produce होगी? जहाँ पे vibrations होंगी, you will be able to hear the sound. So sound is produced. Fine, but there is no molecule to propagate the sound. What is propagation? Traveling. Fine. Sound को एक जगह से दूसरी जगह तक travel करवाने के लिए we don't have the molecules in between. So sound is going to be produced, but it is not going to pass through this jar, and we are not able to listen to that. Is this point clear? There are two terms related to sound. One is the production of sound and one is the propagation of sound. Production is by vibrations अगर वाइब्रेशंस होंगी तो प्रोडक्शन होगी. Fine. Propagation, for this we need medium. Medium means molecules. Either they can be in the state of solid, liquid or gaseous, any form, but molecules होने चाहिए. Depending upon कौन सी स्टेट है, थोड़ा साउंड का लेवल कभी ज्यादा हो जाएगा, बट कम हो जाएगा, लेकिन होगा. Fine. But if you don't have medium, then sound will not propagate. Fine. That means we can say that sound need a medium to travel. Question can be asked that is sound will sound travel in vacuum? No. Why? Because in vacuum there is no medium, there is no molecule, and sound need that. If it is clear, kindly give a thumbs up. Then we are going to proceed on. Hanji, I hope it is all clear till here. Okay, ji. Let's move on with the next. Measuring the speed of sound in air. For measuring the speed of sound, speed का formula क्या होता है? It is distance over time. Fine. So whatever is the distance traveled, divide by in how much time it is traveled. Fine. Okay. So measuring the distance of sound in air. The simplest method to measure the speed of sound in air uses two microphones and a fast recording device such as digital storage oscilloscope. First, the sound source and the two microphones are arranged in a straight line with the sound source beyond the first microphone. The distance between the microphones called the microphone basis is measured. The time of arrival between the signals reaching the different microphone to be measured, and then for calculating the speed we have the formula that is x over t. What is x? X is the distance between the microphones. दोनों microphones में जितना distance होगा divide by how much time is taken. Fine. Speed का simple formula क्या है? We have the formula of speed, that is distance over time. Fine. Speed is equal to distance divided by time taken. Distance traveled divided by time taken. So you have the microphones distance, we can have it as x, time we can have it as t. So this is going to be a formula. You can directly have this one. ऐसा कुछ नहीं है. This is all correct. Fine, सही है. So in the exam, you can have a numerical, a simple straight numerical, where they will be providing you with the distance or the time, distance and the time you have to find out speed. Or distance speed given होगा, time find करना है, और time speed given होगा, distance find करना. Means out of the three, speed, distance, time, two will be given, third you have to find out. Okay. Then you have the topic on the next page, that is the speed of sound in air, liquids and solids, which I have already discussed with you. एक बार इसको बस ये जो 3-4 lines हैं इनको एक बार पढ़ लेना. What I have already discussed with you is that speed is faster in solids क्योंकि molecules बहुत close होंगे. The time of propagation is going to reduce. वो फटाफट आगे पास होते जाएंगे. So speed in solid is maximum. Speed in liquid decreases. The speed in gases is going to be very less. And in vacuum you will not be having any speed. Why? Because no molecules are there, no propagation. Fine? Okay. Then you have a concept of science and context, that is endangering airs. So we are going to read that. The air is far more easily damaged than most people realize. You should always take care both with the volume of the sound and with the length of the time that your ear is exposed to. You are going to read this by yourself. I am going to explain by giving you an example about this. Through that example, the topic is going to be totally clear to you. वैसे ये topic आपको clear है already. Fine. We know that we are not going to use headphones for so long. हम volume high नहीं करेंगे, but we do. Fine. So हमें clear है लेकिन हम करते नहीं, है ना? So let's understand that what is the importance of using the sound. You want to hear, you want to listen the music, you want to enjoy that. That's okay. But there has to be a limit to everything. For example, when you are using the headphone, you increase the volume. After some extent, it is written there. एक alert आ जाता है. Fine. आप volume increase नहीं कर पाते हो. There is alert जहाँ पे लिखा होता है that if you increase the volume above this, it's going to be dangerous. Then again we press और वो increase हो जाएगा. लेकिन alert जरूर आता है. But we ignore it. That alert means, okay, now take an example and understand this. You know about the assembly drum which you have in the school? Morning. So this is the drum sheet. ये आपका drum है. Fine. This is the sheet of the drum. Fine. You are going to beat the drum with one stick or with two sticks. Fine. या तो आप एक stick use करोगे या फिर आप दो sticks use करोगे and you are going to strike the sticks onto the drum and the sound is going to be produced. Fine. Now let's say that you have 10 of the drums all together, 10 of the sticks all together, and you are striking all the sticks together. मतलब 10-12 बच्चे इकट्ठे होकर ठक 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 कर रहे हैं. What happened to the sheet? What is going to happen to the sheet? Andy, if you do this for a long time and if you have 10 of the students using the sticks together, what is going to happen? Yes, Isha said, ma'am, मैंने headphone लगाया and alert is coming. Definitely it is coming. When you reach the half of the level, it comes to the. Okay, so when you beat the drum sheet with 10 sticks together, what is going to happen? I need the answer from you. What will happen? Very good. Ma'am, it will be destroyed. Destroyed, acha. Or anybody else? Dilpreet is saying it will be destroyed. Isha, my question is, this is the drum sheet with which we can strike one stick at a time or two sticks at a time. लेकिन अगर हम 10-12 sticks इकट्ठी ड्रम शीट के ऊपर स्ट्राइक करेंगे तो क्या होगा? What is going to happen to the sheet then? Very good. Okay, again the sheet is going to destroy. Fine. It will be damaged. Very good. Harsh sound to produce होगी लेकिन ये damage हो जाएगी. Fine. Similarly is your ear. Ear में you remember there is an ear drum. Fine. There is an eardrum on which the vibrations they strike and the eardrum vibrates and send the signal forward. उसी के कारण हमें सुनाई देता है जिसको हम पर्दा बोलते हैं. Fine. Now if you go where there is loud music या फिर आप headphone use कर रहे हो, by raising the volume too high, so many of the signals are going inside your ear at a particular time. Fine. The case is same. The way you have this drum sheet and so many of the sticks together. Similarly, दुकान का पर्दा है, the eardrum, and so many of the waves going together. What will happen to the eardrum? The general what we are able to hear, that is 20 hertz till 20,000 hertz. 20 hertz मतलब पता क्या है? 20 hertz means this drum is going to vibrate 20 times in 1 second. और maximum 20,000 hertz मतलब 1 second में 20,000 बार vibrations of the eardrum. Fine. It is okay to have it till 1,000, till 5,000, till 10,000, but beyond that it is you are inviting the problems. Fine. So yes, it is good. And second point, what they have said is, one is increasing the volume, that is dangerous. Second point, increasing volume जैसे ये sheet के ऊपर so many sticks at the same time, that is dangerous. Second thing which is dangerous, इस drum को continuously you are using it for a long time. Fine. Sticks on the drum continuously for a long time, then also it is going to be dangerous. Same way they said that if you are using the earphones, if you use it for 5 minutes, for 10 minutes, for 30 minutes, okay. But there are some those who use it for 2 hours, 3 hours and 4 hours. So if you increase the time also, एक तो वैसे ही problem create कर रहे हो and you have that for a long time. Duration increase kari, that is also going to be dangerous. Fine. So we damage the ears by having the high sound, high music. उसके कारण क्या होगा? Frequency increase कर जाती है. Fine. Plus we have it for a long duration. तो हम एक तो ज़्यादा frequency सुन रहे हैं and we have that for a long time. उसके कारण the effect is going to be more worse. Fine. Okay. Next is the range of hearing. That what I have already told just right now. The range of hearing for a normal person, it goes from 20 hertz till 20,000 hertz. कहाँ से कहाँ तक? It goes from 20 hertz till 20,000 hertz. This is the normal range which a human is able to hit. Fine. If the eardrum is going to vibrate 10 times in 1 second, it means frequency 10 hertz hogi. It means you are not able to hear that. Everything, a little of the sound we are not able to hear. Fine. If the vibrations are at least 20 times, that is the frequency is 20 hertz, we are able to hear it. Above that, we are able to hear, and we are able to hear it till 20,000, which is the maximum. इतना होना नहीं चाहिए, but ज़्यादा से ज़्यादा maximum to maximum is this one. इससे ज़्यादा above this, that is just a noise. कई बार ऐसे होता है ना कि you have the music around you, but you are not able to understand anything out of it. That is just like a noise to you. That means that the frequencies are so high that you are not able to have that. Fine. कोई understanding नहीं हो रही है. This is just a kind of noise. plus that is going to be very dangerous for the ears. Because the eardrum is going to vibrate more than 20,000 times in one second, which is very, very dangerous. Okay? Okay. Now, using an oscilloscope and microphone to display sound waves. Sound waves can be represented on an oscilloscope by using a microphone and a loudspeaker. You can see the diagram of the oscilloscope which is drawn in your book, figure 4.44. Understand what is oscilloscope? Where you will be having the kind of signals. Fine. We have the same kind to like we can see that somewhere in hospitals, or we can have that many of the times in television also. एक screen होती है जिसके ऊपर heart beat आपको दिखाई देती है. Fine. So kind of that. Okay. So sound waves can be represented on the oscilloscope by using the microphone and the loudspeaker as shown in figure 4.44. This produces a voltage time graph for the sound wave on the screen of the oscilloscope. एक आपके पास voltage time का graph बन जाता है. From this graph you can find out the frequency of the sound wave. Since you will know the time taken of the one cycle of the wave, that is the frequency. Fine. So during using this oscilloscope, आपके पास एक graph formation हो जाएगी. That will be having two dimensions, voltage and time graph. Fine. From there you can find out the frequency कितनी है. Like heartbeat होता है ना, when it is totally like this, मतलब frequency 0. 0 means no more. Fine. When it goes up and down like this, means there is frequency. Fine. Okay. Now the same they have drawn. आपको वो जो graph है वो समझाया है by giving you the relation between pitch, frequency. Second is amplitude, loudness. They have not written it the way I have spoken. It is not pitch, frequency, amplitude, loudness, but it means this. Fine. 4 things are there. We are going to do one by one. Pitch, frequency, amplitude, loudness. After that, pitch and frequency, they go side by side. The amplitude and loudness, they go side by side. Okay. So let's do it. Sounds with high pitch have high frequency. For example of high pitch sound include bird song or all the sounds that you hear from someone else, personal stereo, when they have set the volume too high. ठीक है, मतलब जो बहुत ज़्यादा आवाज आती है. Low pitch sound have low frequency. अगर frequency कम है तो मतलब pitch कम है. अगर frequency high है तो मतलब pitch high है. From here you can have one thing. इसको इस पैराग्राफ के साइड पे लिख लो that pitch is directly proportional to frequency. अगर frequency increase करेगी pitch increase करेगी, frequency decrease करेगी pitch decrease करेगी. Got it? High pitch, for example, the high music, the loud music. Low pitch, low frequency, for example, the horn of a large ship or a bass guitar. Bass. The loud sound have large amplitude, whereas quiet sound have small amplitude. The loudness of sound can be compared using decibels. Okay, as shown in figure हम बाद में देखते हैं. एक और relation लिख लो. The way you have written this. Similarly, you can write about amplitude and loudness. They are also directly proportional. Loudness more if the amplitude is more. Loudness less if the amplitude is less. Fine. Loudness, you can understand, you can very well relate to this. Loud means voice is loud or voice is low. That depends upon amplitude is high or amplitude is low. Amplitude क्या होता है? How much high the crust is. Fine. So the amplitude decrease will decrease the loudness. इसको हम ग्राफ की फॉर्म में करेंगे अभी ताकि क्लैरिटी हो जाए. इसको लिख लो. Now I am going to graph it there on your book, but I have to draw it onto the board to make a connect. Okay. So one graph onto your it goes like this. Fine. Second, it goes like this. Now, if you see both the two graphs, amplitude होता है from the mean till the max. This height of the crust or the depth of the crust. So, if you look onto these two figures, इसमें height ज़्यादा है, इसमें height कम है. Means this is having less amplitude, this is having more amplitude. मतलब this is having less loudness, this is having more loudness. This is more loud, this is less loud. Fine. Why? Because amplitude is less, loudness less. Amplitude more, loudness more. समझ में आया? If they gave you 2-3 of the pictures, like it can be in your paper 2 as well, MCQ portion में they can give you few of the pictures and they can ask you that which out of this is having the least of the loudness or the least of the amplitude, whatever the question like that. Fine. तो आपको देखना है ये the height of the crust कम है ज्यादा है depending upon that. Now the next diagram you are going to have it like this. It goes like this. Fine. And and now the next you have it like this. One side you have voltage, one side time. ठीक है, ये मैंने लिखा नहीं है. You can have it like this, voltage time. And the second you have it goes like this. Got it? Now, if they say amplitude, loudness, then in this case, amplitude, height less, amplitude less, loudness less, amplitude more, loudness more. Second is frequency and pitch. Okay? Frequency means in 1 second how many vibrations pass on. Now let's say your 1 second is from here till here. इतना टाइम स्पैन है आपका 1 second. Fine. ये जो टाइम स्पैन है this is 1 second. So if you look into this first figure, 1 second में कितनी wave formation हुई? One crust and one trough is your one wave. तो यहाँ पे कितनी wave formations हुई हैं? 1. The side, one crust, one trough, one wave. Then this is second wave. Then this is third wave. So in this case, in 1 second, how many waves pass? 3 waves. मतलब यहाँ पे frequency है 1 hertz. पे frequency है 3 hertz. Which frequency is more? This. So where the loudness is more? Okay. Loudness, sorry, pitch. Frequency के साथ क्या relate करेंगे हम? Pitch को relate करेंगे. Here the frequency is 1 hertz. Here the frequency is 3 hertz. So out of these two, the frequency is maximum in this case. Therefore, the pitch is maximum in this case, and the pitch is minimum in this case. Is the point clear? How you can have the maximum or the minimum pitch? Okay, it's 12 o'clock. We are going to end the class over here. इस chapter का एक last topic रह गया, that is echo. This we are going to do in the next class, which is by 1:40. That is the 5th lesson of yours is again with me. That is again your physics lesson. We are going to have that by 1:40 and we are going to cover the chapter in that. Fine? Thank you so much. Take care of yourself. Take care of your family. Stay safe. Stay healthy. Bye-bye.